Time. It's the one thing we all experience, but barely understand. What if I told you that time doesn't move the same for everyone? That right now, at this very moment, time is running slower for someone else compared to you? Sounds insane, right? But thanks to the genius of Albert Einstein, we now know that time is not absolute. It bends, stretches, and can even be manipulated. So let's dive into the science of time and figure out if time travel is actually possible. For centuries, humans believed time was a constant, ticking forward like a perfectly synchronized clock. Sir Isaac Newton saw time as an unstoppable force, an invisible background that flowed at the same rate for everyone, everywhere. But then came Albert Einstein, who completely shattered this idea with his groundbreaking theory of relativity. Einstein showed us that time isn't fixed. It's relative. It depends on speed and gravity. The faster you move or the closer you are to an intense gravitational field, the slower time moves for you. This means if you could travel near the speed of light, time for you would slow down compared to people on Earth. When you return, you'd have barely aged, but decades or even centuries could have passed here. Think time travel is just science fiction? Think again. We already have proof that time travel is real, just not in the way Hollywood imagines. Take astronauts aboard the International Space Station. They orbit Earth at about 28,000 km/h, and due to their immense speed, they age just a tiny bit slower than people on Earth. When they return, they are technically younger than they would have been if they had stayed on the ground. This effect is called time dilation, and it's a real, measurable phenomenon. In 1971, scientists flew precise atomic clocks around the world on jet planes and compared them to clocks on the ground. The results? The moving clocks ticked slightly slower than the stationary ones. The difference was tiny, just nanoseconds. But it proved that time dilation is real. But what if we took this to the extreme? If you boarded a spaceship traveling at 99.9% the speed of light, time for you would slow down so much that while you experience just a few years, centuries could pass on Earth. This means, in theory, you could travel to the future. No magic required, just physics. And it's not just speed. Gravity can also bend time. Imagine standing near a black hole, where gravity is so intense that even light struggles to escape. Time would crawl for you, while the rest of the universe speeds ahead. If you somehow escaped, you'd find yourself far into the future, while only moments had passed for you. So, we've established that traveling forward in time is theoretically possible. But how close are we to actually doing it? Right now, our biggest challenge is technology. The speeds needed to significantly slow down time require energy levels far beyond our current capabilities. But if humanity ever builds near-light speed spacecraft or harnesses black hole physics, time travel to the future may become a reality. So, is time travel possible? To the future? Absolutely. To the past? That's a different question, and one we'll tackle in the next part, where we explore whether we can ever travel backward in time without breaking reality itself. Stay tuned. So far, we've explored how Einstein's theory allows us to travel forward in time and how wormholes might let us jump to the past. But there's one more frontier left: quantum physics. Could the strange world of subatomic particles hold the key to real-time travel? In quantum mechanics, particles can become entangled, meaning their states remain connected no matter how far apart they are. Some scientists believe this phenomenon could be linked to time itself. What if manipulating quantum entanglement could allow information, or even matter, to move backward in time? Some researchers suggest that quantum computing could simulate time loops, potentially giving us a new way to understand and even control time itself. This might not mean stepping into a time machine, but it could open doors to sending messages across time, or even predicting events before they happen. Will we ever master time travel? The science is still unfolding, but one thing's for sure: time is far stranger than we ever imagined. What do you think? Could quantum physics hold the answer? Let's discuss in the comments. If you love mind-blowing science, don't forget to like and subscribe for more deep dives into the mysteries of the universe.